I've replaced our standard PoE switch to our PoE++ switch, and let's wire this the right way. Hi tech lovers, welcome back to FASTCABLING. So today we are turning a tricky brief into a clean, reliable PTZ camera network. So our client runs a big parking complex, multi-level garages, long open driveway, and building edges that all need 360-degree coverage for security, traffic flow, and incident capture. That means a lot of PTZs are moving, zooming, and switching on IR at night. Now, at the heart of any PTZ deployment is power over Ethernet. Just one network cable carries both power and data, so installs goes faster and look cleaner. And for a parking complex, that's gold. Fewer conduits, fewer power spurts, and easier maintenance. And before we touch a cable, let me show you our client's baseline setup. He has a standard switch connecting to the PTZ camera. And I will show you the wrong turn they took. There's where many projects fall over. PTZ works fine until the IR infrared turn on and the pan to zoom features are on. Now soon you'll see black and white images, but then it stopped. PTZ don't just sip power, they spike. When a PTZ camera pan to zoom while firing IR LED and running analytics, it can peak around 30 to 40 watts. And if you plug that into a port that only does standard PoE, that's 802.3 AF, about 15 watts, or even 802.380 PoE plus, up to 30 watts, you're on the edge. So the result is reboots when the head moves, frame drops when IR kicks in, and sometimes a camera that looks dead, but it's actually brownout cycling. And that's our pain point number one. Individual port that cannot meet the peak draw. And pain point number two is the total power plan. Our client's last installer sized their switch by average power. Now it worked at noon, then collapsed at night when every PTZ moved and the IR switched on together. And that's why we stopped thinking in average and size for simultaneous dynamic load. So our fix is PoE++, IEEE 802.3 BT standard. In simple terms, PoE++ delivers higher power by using all four wire pairs and smarter power negotiation. So each port can fit demanding devices like big PTZs, Wi-Fi 6 or 7 access points, and signage. And our backbone today is this L3 managed 24-port switch with a 720 watts PoE budget. So it has total 720 watts power budget. Plenty for our system. And PoE++ capability, also for 10G SFP plus uplink, gigabit access port, and layer 3 management for VLANs, QoS, link aggregation, and monitoring. So it's exactly what a high-density, multi-building parking site needs now and in the future. And those SFP plus ports are future-proof for fiber runs between buildings and a 10G spine back to the recorder or VMS cluster. So we won't outgrow the backbone when more cameras arrive or analytics bit rates increase. So now I've replaced our standard PoE switch to our PoE++ switch, and let's wire this the right way. First, let's talk about cable choices. For PoE++, you should stick to solid copper, not CCA, like Cat5e or Cat6 cable. And outdoors, go gel-filled, direct burial, or UV rated with shield. And you should keep runs under 100 meters per Ethernet specs, but if you must go longer, I'll show you a few safe ways later. So now it is already powered up. I'm going to connect the network video recorder to one of the ports. Now on the switch, we can label the ports by location. And this model is 720 watts pool, give us the confidence to take simultaneous peak. And PoE++ port can deliver up to around 90 watts when a device asks for it, which is exactly what high-power PTZ want during heavy moves or when the IR infrareds are on. Now let's give it a minute. Now we can see our PTZ camera is on. And again, I'm going to stick a sticker here to turn on its IR infrared so it takes more power. But this time, let's check it out. This time the PTZ camera is working perfectly fine. So we solved the PTZ power problem, but we had one more curveball. Our client told us this one PTZ camera has to place 400 meters from the switch. That's 4 times the Ethernet limits. And here's the safe and clean answer. This direct burial extension kits creates a long 300 meters PoE segment between the 2 rugged extenders and up to 500 meters total, deliver gigabit speed and support PoE++. It's waterproof, designed for direct burial, and it's plug and play, no extra power out in the field. And because it's built for continuous run, so we avoid daisy chaining a bunch of little extenders. So now let's mount it on our wall. Now here we have the 100 meters Ethernet cable from the PoE++ switch. We run the copper to our first extender. Using PoE++ at the source can help fight voltage drop over distance. And you can start with a higher power budget so you still deliver enough at the far end when the PTZ hit its peak. Now I'm going to unplug the PTZ camera and take our 100 meters Ethernet cable here. It's too long now, let's wrap it around. And we are going to connect to our first extender. Now normally you plug it into the input port, right? But for our kits, we have to flip it around. So from the PoE++ switch, we are going to connect it to the output port. So let's connect it to the output port here. And then we use a big row of 300 meters Ethernet cable connect to the input port of the extender. So let's plug it in. So total we get 400 meters. 100 meters from the switch to the first extender and 300 meters between our 2 extenders. So here we have our second one. Now for installation, you must use a wrench to tighten the neck and the gland for IP67. But now I'm just to take it out so we can do a fast installation. Remember, we have to put input facing input. So now I'm going to connect the 300 meters Ethernet cable to the input port of our second extender. Then connect a short patch cord from the output port to our PTZ camera. Let's mount it on the DIN rail and directly to the Pentile zoom camera. So we have one result. One trench, no mid-span AC, and a PTZ that stays on at night. So now that we've solved the furthest run, let me show you a few standard ways to extend up to around 200 meters where only a little extra reach is needed. Now if you're powering one device, let's say one high-power PTZ or one high-power access point, you can use this 1-in, 1-out PoE extender that support IEEE 802.3 AF, AT, and BT standard. And you can feed by a 95 watts injector standard or the PoE++ port on the switch. And if you get two devices, let's say a PoE with a PTZ and a bullet camera, then you can use this. This is our 95 watts 2-port waterproof PoE extender. One feed in and two PoE outs at the pole, and with one port up to 60 watts and the other up to 30 watts output available, also delivering gigabit speed. And lastly, if there are a cluster of cameras near each other, you can step up to an outdoor PoE pass-through switch. Now it's IP67 weatherproof, and this outdoor model can even fan out to as many as 7 ports from one single incoming cable. Alright, so let's land this. We moved from unstable PoE Plus to a PoE++ core that handles real-world peaks. The result is smooth patrols, clean night visions, and a system that's easy to expand. If you're planning a high-density PTZ rollout, parking structure, campus or stadium, power budget, and long-run design are everything. Now, thank you very much for joining us. Hit like if this video helped and subscribe for more hands-on builds. Feel free to tell me in the comment section below what you want us to tackle next. And I'll see you in the next one.